Hello, 6th and 7th hour. Today we are going to revisit gas and the 4 different ways we can measure gas, as well as 3 ways we can increase pressure. I'm going to start. Yesterday, or the day before yesterday, depending on which class you're in, we took a look at an experiment. And in this experiment, we had different flasks. And in those flasks, we saw these little particles floating around. And those are gas particles. So before we talk about measuring gas, I just want to take a moment to explain that gas is just like any other kind of matter. It just has more, oh, you can't see that color, more energy. So you're familiar with solids. You interact with them every single day, as you do liquids and gases, but they hold still, they have a nice shape, and they don't go anywhere. Liquids, on the other hand, can flow around. They have some energy. They're moving around a little bit. Gas particles, on the other hand, are similar to a very energetic 5-year-old. They are flying all over the place, bumping into each other, bumping into the walls of the container. There's really nothing that's going to stop them. I had a student ask me yesterday whether they ever got tired, and the answer is no. They continually move all the time. That's why they're called gas particles. Okay, now that we know that gas is made of particles that are always moving around really fast, let's take a look at ways we can measure them. So first, we're going to take a look at ways we can measure them. We can measure using temperature, volume, pressure, and number of particles, i.e., this is number 1 on your sheet. There are several different ways, so let's talk about what those mean for us right now, and then I'm going to talk about what they mean for gas particles. So for temperature is really, oh, you can't see that, so it's over here. Temperature is just the way we feel something as hot or cold, okay? Now, temperature for gas particles really means speed, and I'm going to talk about that in a little bit. Volume means how much space something takes up. So you think of maybe a ladle or a cup having a smaller volume than a pitcher or a large bucket. So volume is space. Space is spelled with a C. Pressure is kind of like how things push on each other. So you're familiar with the pressure of your car tires or the pressure in your blood vessels. In the case of the car tires, the pressure is the pressure of the gas pushing out on the inside of your tires on your car. In case of your blood, this is the pressure, if I have a blood vessel, that the blood is actually pushing out on the vessel walls. So pressure in either way is when something that's moving pushes out at the outsides of its container. Then finally, we have number of particles. So number of particles should be a little bit simpler. It's really just when I have more things moving around, I have more particles. When I have fewer gas particles, I have fewer gas particles. It's the same number of things as when you're counting apples or oranges or text messages. Now we're going to talk about pressure, except here we're going to talk about pressure in terms of the gas particles. Remember that they're little guys that are just kind of flying all over the place and bumping into things. Pressure is the force of the gas particles colliding with the container. So we're not worried about how fast they're going. We're worried about how much they hit this container. So if I have a lot of gas particles that are all hitting the container, that means my pressure might be greater. And that would allow them, see here where we have the same weight on both sides, if I have more pressure, the gas inside is able to push up this weight higher, which is because it's having more collisions or it has harder collisions. So pressure is the collision between the gas and the container. And it can sometimes cause the container to change volume, or temperature can cause pressure changes, but we'll talk about that bit later. Remember, particles colliding with container. Now you need to describe pressure in your own words for number 2. Volume should be a little bit simpler. For volume, we're really just talking about the amount of space the gas takes up. So here we have a volume. That's the green stuff is the gas. And here we have a different volume. So you see this gas is taking up more space than this gas. Very simple, pretty straightforward. Now I want you to come up with 2 things that hold the gas in your life. I've mentioned several examples already that you're welcome to use. And you need to identify which one has the larger volume. Temperature is the average speed of the gas particles. So here we can see that the temperature is pretty low in this container and pretty high in this container. That tells me that the gas particles moving around in this container are going slowly, versus the gas particles in this container are moving very fast. So even though temperature to us means hot and cold, if you were to look at something that's very hot versus something that's very cold, you could see an actual change in the speed of the molecules of that material. Now, sometimes they move within themselves, and we won't get into that. But I want you to think about these particles at the lower temperature move slower, and these particles at the higher temperature move faster. So temperature is like how much energy, on average, do the gas particles have? And that energy translates directly into how slow or fast they are. Now you need to describe gas temperature, not gas, describe temperature in your own words. So from here, I have just described the 4 variables that we can describe gas with. One was temperature, volume, pressure, and at the very beginning I talked about number of particles. Now we are going to talk about how temperature, volume, and the number of particles can change the pressure. And remember, pressure is the force that molecules put on their container. So when they smack into the side of the container, how much force are they putting on their container? That's pressure. So we're going to use these 3, and we're going to fill in how they change pressure. You should be filling in number 5 as we work through this. The first variable we're going to talk about will be volume. So between these 2 containers, which one has a smaller volume? You should be looking at this one right here. So you can see that the plunger is up here and it's been moved down, but the number of particles inside has stayed the same. Now, if we think about pressure as the number of times and the force which it hits its container, if I have all of these particles all stuck in here together, then they are going to be having a higher pressure. Because when they're all stuck together, that makes them smack the walls of the containers more often. Whereas when they have a larger volume, they have more room to move around before they're going to hit the wall of their container. So as we can read down here, as pressure increases, the gas of molecules can have more collisions, okay? And pressure is increasing because volume is getting smaller. So if we look here, a decrease in volume will increase pressure. Next up is temperature. Here I have a lower temperature container, and here I have a higher temperature container. You can actually see that this container has a higher pressure because it has more weights sitting on top of it. So in order to counteract the force of these guys pushing up, it has to push down harder. Whereas these low temperature gas molecules are pushing up with less force. So in order to keep it closed, I just need less force in response. So let's also look here. I want you to pay attention to these arrows. These arrows tell me how fast something is moving. We call them vectors. So if something has a larger arrow, we know it has a higher temperature. Whereas if something has a smaller arrow, we know it has a lower temperature. So we can conclude that the higher the temperature, if I increase temperature, it's going to cause the gas molecules to go faster. We can summarize this observation by saying faster molecules hit more often and with more force, which increases pressure. So we can say increasing temperature increases pressure. Finally, if I add more gas, I will also increase pressure, because if I have more things stuck in the same container, they're going to bump into the side of the containers more often because there's less room. Okay, so adding more gas will increase pressure. So now you've looked at the 4 variables and the 3 ways to change pressure. And you need to do number 6 and 7 and 8 before you are done.